CSharpNumerics, a comprehensive numerical library for C#. In this episode, I will talk about our new simulation engine, GeoEngine. So the basic idea here is that I have a physics model. I use a stochastic algorithm, Monte Carlo, to simulate n scenarios. From this, I use machine learning and clustering to find the scenario that has the highest probability. And this is then exported to a GIS format. This works with a fluent API for risk scenarios. So for risk scenarios, you can run a simulation for Gaussian plume. You could add the wind as input parameters, variation, over grid, over time, how many Monte Carlo simulation you will run, and you can also add a cluster grid to analyze with. So in machine learning, in a previous video I talked about supervised auto ML, and we also added unsupervised auto ML, and it's based on the same idea. You have a cluster grid, you can add your models, KMeans DBSCAN, and you can also add several hyperparameters. What the algorithm will do is to find the most optimal model and the most optimal hyperparameters for our scenario. Yeah, and here you can also see that you can export it. You can export it to GeoJSON. You can export it to Cesium. We can also add materials in our pipeline. In this case, I add a radioisotope Cesium 137. So in physics, I added a section for environmental. Here we have our Gaussian plume models, and I also added a section with materials, and in this now we only have the nuclear ones. So let's test this in Unity 3D. So I will add a new game object. I will, in the inspector here, add a component, and I loaded my asset here, and so I can find the demo simulation. In the right section here, you will have several input parameters. You can change the longitude and latitude. In this case, I'm using Malmö. And you can change the wind direction, and also how many Monte Carlo iteration you want, and also which kind of radioisotope to add to the simulation. So the simulation, you can see the puff here, and the red area is very high probability that the smoke, but in the green areas it's lower probability that the gas will spread in that direction. We can press C here. See, then we cycle the view, we can see the radiation. If we press M, we will get the statistics for the clustering algorithm. And we can see here that KMeans is the best performance. It has a hyperparameter K of 2. It has a score of 34.8. And with this elevator, it's actually a very good score for plume simulation, and it shows that the clustering has good separation. Yeah. This will be available at Unit Asset Store in a week. So I will add the description in the video. So yeah, thank you for listening, and have a nice day.